We've seen measuring the angle of refraction using a semicircular glass block. What we're going to do now is do the same experiment with a rectangular glass block. So what I'm going to do first of all, much like I did before, is I'm going to draw an outline around the block like so. So I'm going to use one of the lines on the graph paper to help me so that it makes it easy then for me to draw in the incident rays and the normal. So that's where I'm going to place the glass block. I've put a shadow there so I can put it back in exactly the same place. Now I need to choose a place where I'm going to send my ray of light in. So I'm going to send the light in somewhere over here. So I'm going to make this angle, this line on the graph paper, my normal. So I draw in like so, and that's at 90 degrees, and this is the normal. Now what I'm going to do is draw in, like I did before, the incident rays. So I need to first of all measure the angles in. So we have 10, 20, 30, 40, 50, 60, 70, 80. And so now I'm just going to draw in some lines because I'm going to use these to send the rays of light in so I can get the angles accurate. So that's 10, 20, and these are my incident rays, 30, 50, 60, 70, and then finally 80. So just label them, just makes it easier then to work out what's going on later. Okay, so I've now, as before, set it up so I can send in my rays of light in there. I'm going to place the glass block back on the shadow, and then in a second I can send the light in along these angles, and what I can then do is mark out where they come out. So once again I send the rays of light in along each angle, and I'm just going to mark out where they come out of the block. So there's the ray going in, and it comes out over here, and I'm just going to put a little mark here. You could use, and you do see in some questions, using pins. So this is a pin board, and then they put a couple of pins there. But I'm just going to put a couple of pencil marks on this one, but it would achieve the same result if you had pins. There was an exam question in about 2019 that had something similar. So I put a couple of marks there so I can draw in the rays. And there's 30. 40. 50. 60. And then the last couple. So there's 70. And then finally 80. Okay, so I can now take the block away, and what I'm going to do now is I'm going to draw in the rays as they come out of the block. Okay, so the ray came in at 10 degrees and then it's disappeared off in this angle here. So you can see that it's coming at 10 degrees, and this is the angle that we're going to measure. This is the angle of refraction. And what I want to do is do the same for each of these rays. So let's just draw these in. Okay, so there's the angles coming out. What you notice is that it refracts again when it leaves the glass block, so it does change angle again. So if I was to draw in the ray, it would come out. So there's a refraction, change in speed here, and a change in angle. And then there's also a change in speed here as it leaves the glass block, and that changes the angle as well. So we're just interested in these angles here. So I'm going to measure them in. So take that. Okay, so that is 8 degrees. This is 14 degrees. That is 21 degrees. That is 27 degrees. That is 33 degrees. This is 39 degrees. This is 43. And then finally, this last one is at about 47 degrees. Okay, so I've worked out, these are the angles of incidence, so 10 degrees, and then the angle of refraction coming out is about 8 degrees, and so on. So I've worked my way around the sheet. So now I have my results. What I can do is I can tabulate these. So I tabulate the angle of incidence, the angle of refraction, and then I'm going to use that to draw a graph. And I draw a graph of the sine of 10 degrees against the sine of 8 degrees. Okay, that's what we're going to use to help us prove Snell's law.